For most of human history, people believed time was absolute. 1 second was 1 second, everywhere, forever. Ancient civilizations built calendars, sundials, and clocks believing time flowed the same for everyone in the universe. No matter where you were, time was thought to tick at the same speed. This idea stayed unchallenged for thousands of years. Even Isaac Newton, one of the greatest scientists who ever lived, believed time was fixed and universal. According to Newton, time moved forward at the same pace for all observers, no matter what. This belief shaped science for centuries. But in the early 1900s, one man changed everything. His name was Albert Einstein. Einstein proposed something radical. He said, time is not absolute. Time depends on motion and gravity. The faster you move, the slower time passes for you. And the stronger the gravity, the slower time flows. At first, many scientists didn't believe him. The idea sounded absurd. How could time change? How could two people experience time differently and both be correct? But Einstein's equations predicted this behavior exactly. According to his theory of relativity, gravity is not just a force pulling objects together. Gravity bends space itself. And because space and time are connected, bending space also bends time. This was a completely new way of understanding the universe. On Earth, we don't notice this effect because gravity is relatively weak. But it still exists. Time moves slightly slower at sea level than it does on a mountain. Atomic clocks placed at different heights tick at different speeds. Even today, satellites must correct for time differences caused by gravity and motion. Without these corrections, GPS systems would become inaccurate within hours. So Einstein was right. Now imagine pushing this idea to the extreme. Imagine gravity so powerful that it completely dominates space and time. This is where black holes come in. Black holes are formed when massive stars reach the end of their lives. When the fuel that supports the star runs out, gravity takes over. The star collapses inward violently, crushing itself into an incredibly small region. The gravity becomes so intense that nothing can escape it. Not matter, not energy, not even light. That is why black holes appear black. At the edge of every black hole is a boundary called the event horizon. This is not a physical surface. It's a point in space where gravity becomes so strong that escape is impossible. What makes black holes truly fascinating is what they do to time. As you move closer to a black hole, gravity becomes stronger. And as gravity increases, time slows down. If an observer far away watches someone falling toward a black hole, they see something strange. The falling person begins to slow down. Their movements stretch out. Their clock ticks slower and slower. Signals sent from the falling person take longer to arrive. Their image becomes dimmer and redder. To the distant observer, the falling person never actually crosses the event horizon. They appear frozen in time. But for the person falling, the experience is completely different. They don't feel time slowing down. Their heart beats normally. Their thoughts continue normally. Their watch ticks just as it always has. They cross the event horizon without noticing anything special at that moment. This creates one of the most shocking ideas in physics. Two observers see two different realities, and both are correct. This is not an illusion. This is how the universe truly works. Now consider this scenario. Two astronauts begin together. One stays far away from a black hole. The other travels toward it, hovering near the event horizon for a short period before returning. When they meet again, the difference is dramatic. The astronaut who went near the black hole has aged far less. While hours passed for them, years passed for the astronaut who stayed behind. This is called gravitational time dilation. It means black holes allow a form of time travel, but only forward. By slowing your time relative to the rest of the universe, you jump into the future. In theory, someone could approach a black hole, spend a short amount of time near it, and return to find the universe far older. Stars may have died, new stars may have formed, Entire civilizations could have risen and fallen, all while the traveler experienced only days or weeks. This idea is not science fiction. It comes directly from equations that have been tested and confirmed. However, approaching a black hole is extremely dangerous. As you get closer, gravity becomes uneven across your body. Your feet experience stronger gravity than your head. This stretching effect is called tidal force. Near smaller black holes, this force would tear you apart before you ever reach the event horizon. Near supermassive black holes, like the one at the center of our galaxy, tidal forces are gentler at first, meaning you could theoretically survive longer. But once you cross the event horizon, escape is impossible. Inside, space and time behave in ways we barely understand. All directions lead inward. Moving forward in time means moving deeper toward the center. According to physics, the center of a black hole contains a singularity, a point where density becomes infinite and the laws of physics break down. Scientists still don't know what truly happens there. Some theories suggest space and time end completely. Others suggest new physics beyond our understanding. Some even speculate about connections to other regions of the universe. But regardless of what lies inside, black holes have already taught us something profound. Time is not universal. There is no single clock ticking for the entire universe. Every object carries its own time, shaped by gravity and motion. Somewhere in the universe, near black holes, time flows so slowly that massive cosmic events unfold elsewhere while almost nothing changes nearby. Galaxies collide. Stars explode. Light travels billions of kilometers. And near the black hole, only moments pass. This means the universe is not synchronized. It is a patchwork of different time flows, all happening at once. So when we say time is relative, we mean it literally. Time bends. Time stretches. And near a black hole, time almost stops. For centuries, humans believed time was absolute and unchanging. But black holes revealed the truth. Time is flexible. Reality is far stranger than it seems. Near black holes, seconds can replace years, and the future rushes forward while you barely move. If this video changed how you think about time, subscribe for more deep space and physics stories that challenge reality itself. Because once you truly understand time, the universe never looks the same again.